Recording started.
Hmm. Okay. So in this session, we're going to revise Maths 2 for Quiz 1, right? Uh, by the way, do you guys, any of you have any issue regarding opening your mic or anything? You can post it in the comment box. That is fine. I'll come back to it if it's necessary. Um so, since it's revision, let's not spend any more time and start away. The first thing, I think it would be best if we go week by week, and since we all know how math to, uh, especially how our Sarang Sane sir has taught us, I would avoid as much as possible his lectures. And pardon me if I don't follow the topics serialized in a serialized way or anything like that. I will go. Uh, okay, but it will be easier if we go on doing it in a very serialized way. Yeah, I know I'm on recording. I'm not saying, we all know that it would be very hard to understand his lectures, and that is fine. Not all sides are same, and that is not a crime to say, I think. Anyway, so the first thing I would like to look upon is the week one, which is, let me share my screen. Uh, and on that note of Sarang Sane sir, after completing foundation and getting into diploma, I have my respect for him has increased a lot because he's quite a good teacher. You would understand if you go into diploma, you would understand that he has given his all while teaching those topics and in those lectures. You'll see. I won't say anymore. He's actually a good teacher, and as far as I've learned, he's actually a good human being as well. So anyway, let's get into the topics. So first week, let's start with the week one, and first of all, tell me if my handwriting is clear or not. Is clear, I think. Okay. So first is, I think the basic thing is matrix, matrix and determinant, right? So we all know what is a matrix and what is a determinant, and it's not important the theory of it or the theme of it or the philosophy of it. Matrix is the set of arrangement of a numbers. Determinant is also another arrangement of numbers, but the difference is you can calculate the value of a determinant. You cannot calculate the value of a matrix. It's just an arrangement, and you do operations on it. You would uh, use it in various places, and most importantly, in our degree, in uh, in higher mathematics and in all the applications, matrix is, I mean, it is so important that you see later. Anyway, right now our concept is about the properties of matrix. So the first few things I want to refresh is the various types of matrix. I think most of you know about those. I'll just rehash. Like the first one I'd like to talk about is called diagonal matrix. You know what is that? The matrix which has, suppose it's a matrix of n by n order, which has all the elements. Is anyone is not being able to watch the screen?
It's fine.
Okay. Oh, Ashwani said, then why he just messed up in the foundation? I just said that he maybe okay. Let's I'll talk about it later. Anyway, In the diagonal matrix, we all know there are diagonal elements, d1, d2, 2, and all the elements are zeros, right? All the elements are zeros. That is diagonal matrix. And uh, there is another term I'll tell you that is not important right now, but it will be important later. These diagonal elements are also called eigenvalues. What is eigenvalue? What is eigenvector? That is not important right now. Just remember this term. It will be important later in diploma. So, um, if diagonal matrix, all the diagonal elements are one, then it becomes a identity matrix. We all know that as well. For example, if I go by 3, this is identity matrix. Yes, Harsh said the exact reply I was gonna give. Anyway, then I don't need to elaborate it further. Uh, okay, so um, next is upper triangular matrix and lower triangular matrix. And let's change the color a bit. So upper triangular matrix is like where eigenvalue is not important right now. I just said this diagonal matrix, all the diagonal elements are also eigenvalues. Diagonal elements are also eigenvalues of that matrix. What is eigenvalue? What is eigenvector? You will learn about it in MLF, Machine Learning Foundation. So I'm not like dwelling on it further because it's not important for your foundation. Just an important anecdote, like it will be important for you later, not now. No, it's okay. Eigenvalue is not important for you right now. It's in foundation. That's fine. Uh, okay, so upper triangular matrix. Upper triangular matrix is the matrix where all the upper values, like there are upper elements and the lower elements are zero. For example, if this is A11, A12, A13, then this is zero, then A22, A23, then this is another zero, and A33. So you can see this diagonal line, I mean the diagonal terms, the right side of it, the upper side of it has non-zero elements, the lower side of it has zero elements. Similarly, for lower triangular matrix, it's the opposite. If it's the diagonal elements, then the lower side will have non-zero, the upper side will have zero. I mean, I can use the term as well. A11, A22, A33, and you can use A21, A31, A32, and this is 0, 0, 0. This is our triangles. And the fun part, and you'll see a lot of questions in math 2. That is another reason math 2 seems so tough subject, because in the GA or in the AQ or in the exam, you will see certain questions that won't make sense right away, because there are certain properties that is not being discussed in the lecture directly, or maybe indirectly, but not directly. Like there's a simple property here that determinant of a triangular matrix is the product of its diagonal elements. Determinant of U, for example, if this is the diagonal elements are u1. For example, if I use let's no let's keep it that way. A11, A22, A33. For this one, I should have kept it as B. Oh, that would make more sense. Yes, product of the diagonal elements. Uh, Another product property is, this is one property. Another property is, you may ask why this is important. I cannot tell you right now because I cannot show you any example problem right now, but you be sure that it will help you in one way or another. These products, these properties. The second one is product of two upper triangular. Okay, no, the triangular matrices are invertible. The triangular matrices are invertible. Invertible, you know what is invertible is? Invertible. You know the term? What is invertible? It means if someone is joining outside the IT. Shun Shankar, are you there? Hello? Shun Shankar? Maybe he's not. Anyway, uh, okay. Okay. Invertible means if the inverse exists. We'll get into this later. What is inverse matrix and how to calculate it? I think most of you already know from school mathematics, school level mathematics. But anyway, so triangular matrices are invertible, means inverse exists. Inverse is possible if all the uh, diagonal elements are non-zero. Okay, so basically all the diagonal elements, these values, if they are non-zero, then inverse exists. Acha. Next is, okay. Next is identity matrix. I've already told you. Next is inverse matrix. I think you know what is inverse matrix is. So the inverse of, if A is a matrix, and first of all, if A is a matrix, and first of all, it has to be square and non-singular. Mic is not working from the phone. Uh, I mean, from your end. Okay. Is that you trying to join? Okay. I see the name as Bolu, but okay. So square matrix, you all know what does that mean? Square matrix mean n by n, means the row and column will be same, number of rows and columns. Non-singular means determinant of A is not zero. Yes, n by n. Let me check the, yeah. So inverse matrix exists only when it follows these two properties. Either one is square and another is non-singular. So otherwise A inverse won't exist. So inverse of A is A inverse. And we know how to do it. We can we'll get into the minor cofactor part. More about it in a bit later. First of all, tell me if any one of you have any doubt up until now. Okay, I think not. So the first week deals with vectors as well, and I don't think there are many much important part to be uh, like misunderstood, that you can mess up in understanding about vector, because the vector in the first week they just covered the basics, right? The addition, how the addition works, and what is the basic properties of it. Like for example, they showed if for example they just asked, for example, if v1 is equal to 1 2 and v2 is equal to 2 3, then what is 2v1 plus 3v2, for example, stuff like that. And apart from that, I don't think there is much about vector here. uh, so I will go into the, yeah, let me check first. Mm, yeah, system of linear equations. So by the way, is any of like all of you are having issues with your mic, like you have difficulty talking or you are not in the environment to reply, because it feels like
No, sir.
No,
We
no,
can
there is no
speak.
any problem.
no, like because it's like I'm talking into the void, and that is very discomforting. Okay,
We are
you
listening.
yeah, and reply if you feel like, and if you want to discuss, and if I'm missing out anything, because I'm not technically your sir, I'm your senior. That's all. Okay, so you can talk. It's not a hardcore session that you have,
Okay,
don't, you're not supposed to talk. Anyway,
okay,
so yeah, so the next thing is inverse. I'll talk about later. Next thing is matrix multiplication, and I think you know about that as well. Matrix multiplication is possible. I mean, addition happens. First of all, addition happens when matrices are of same order. Only then, right? I mean, m cross n and m cross n only then happens. M cross n cross n, not going to happen. I mean, forget the casual notation, but anyway, matrix multiplication is something else. It can happen in same order. It will happen in same order, but there is a particular rule about it. It can happen between two matrices only when it follows this pattern, like the number of columns in the first matrix and the number of rows in the second matrix is same. Absolutely, then the multiplication will happen, and the resulting multiplication will have the number of rows as m and the number of columns as p. This beautiful rhythm, m cross n, n cross p, and the result is m cross p. Let me wait. Someone else is trying to join. Okay, so where is this? Yes. So do you need any example for this, or you know the matrix multiplication already? Should I assume that?
We know it. We know it.
Okay. Next is then system of equation. So you know basically that if there is a equation set of equation, for example, a1 x1 uh, b1 x2 c1 x3. Let's not get into the complicated part of it. 2 by 2 is enough. a2 x1 b2 x3. So you can transfer this set of equations into a format of matrix multiplication, that is uh, a1 b1 a2 b2. Oh, you can use c1 c2 here. Where this is the matrix containing the coefficients, this is the matrix containing the unknown variables, and this is the matrix containing the um, Ravindra. Okay,
Yeah,
Ravindra.
I have one question. Is it any time possible that the variables will be three? For an example, a1 x1 plus b1 x2, and in the second equation a2 x1 and b2 x3. Is it
Yeah,
possible?
of course possible. Let's
So
see that one. Ah, yes, then.
then, how do we write that variable
Okay.
vector? That
Okay, so in that case, you have to since what is you have to check what variables are missing in which equation. Like in this equation, what is missing? X3 is missing. In this equation, what is missing? X2 is missing.
right, right, right.
So you have to rewrite. I mean, it's not necessary, but the first time, if you're dealing with such scenario for the first time, it's better to rewrite it like this. For x b1 x2, and we don't have an x3. Since we don't have an x3, we can assume there is a zero coefficient for it.
Got it, got it. Yeah, solved. Yes, thanks.
And similarly, it will be 0 x2 to x3. And then you will do the same thing with the zero in place of the variable.
Yeah, got it. Thank you.
Okay. Subspaces and dependencies. Okay. Okay. Maybe my mic is maybe because of the, I mean, I'm suffering from a bit cold, so maybe that's why. Yeah. So next one is uh, let's let me check first. Yeah, right. Determinants. So as I've seen, determinant that, I mean, I don't know, in this degree they show it is a matrix, and then matrix A, then this call it like calculate it as determinant of A. In school, I used to do, I mean, we used to do it this way. Matrix had this symbol, and determinant had this symbol. So if sometimes I write it that way, don't think of it as a mistake, because that is by habit I do it. Anyway, so determinant of A, like if A is, if A is A, I mean, it would be better if we go for the smaller version. Uh, so determinant of A in that case is A11, A22 minus A21, A12, right? The uh, cross multiplication. And uh, if this is the 3 by 3 order, for example, A11, A12, A13, A21, A22, A23, A31, A32, A33. And there are many ways to expand this. If I expand it along this row, then A11 and 2, A22, A33 minus A32, A23, and then minus. Why minus? Because this sign changes, plus minus plus, then again minus, plus minus, then again plus minus plus. More, if I go beyond that, these signs come from the indices, like the number of the placing, the row and column placing, because minus 1 to the power 1 plus 1, minus 1 to the power 1 plus 2, minus 1 to the power 1 plus 3, and so on. Is that clear? Is that clear to everyone? So then A12, if I take A12, then it is better to cancel this out and take the rest of it. Then it would be A21 into A33 minus A31, A23, plus the rest is A13. The similar thing, cancel this out and take this part. A21, A32 minus A31, A22. Anyway, this is one way of expanding. You can expand it along this way. You can expand it along this way. And the ultimate result will be same. The next will be, I think, determinants. Yeah. So let me check if there are any properties I need to mention here or not. Uh, right. Right. So the next has to mention. Right. That is the issue with math too. There are so many things at the same time. The order is confusing.
What is the terms in that bracket called? Is it the span or something else?
Which is
Like for A11, you have written in bracket A22 into A33 minus A32 into A23. So that part in bracket, is it the called the span or something
no,
else?
it's not the span. Basically, what you're doing is, when it's 3 by 3 matrix, like for this one, you are doing is A11 into the thing goes like this. Actual expansion is this, minus 1 to the power 1 plus 1, the placing of the element, into
Mm.
determinant of the rest. This is called minor, the minor of the
Okay.
matrix. So that is being what to say, that is being included here. This is the minor determinant of this portion is called minor. for this element. So A22, A23, A32, A33. The next one is like minus 1, 1 plus 2, A12 into determinant of what is left. If I take one, A12, A21, A23, A31, A33. Span and all those things, that is not from week 1 or week 2, that comes in week 4, I think. So it's not a part
Okay,
of the week
and
1 anyway.
minor is without sign or with sign?
Minor is without sign. With sign, if you take sign, it will become
Hmm.
cofactor. Like
Okay.
if I this is called minor m, and if I take this and join this will become, I mean, minus 1 I plus j minor ij. I mean, you can understand what I'm talking about ij here, like I plus and j
Yeah.
plus. Like for example, this is I, this is j, so that becomes cofactor. You get it?
Okay. Got it.
Or better yet, I copy this and do this, do it this. This is your cofactor. And minor is this, right?
Got it.
I think the recording is available. Okay, wait. Okay, I think the recording is available in the YouTube channel, Nilgiri YouTube channel. I haven't checked the channel yet. I think you can get it. You can get the response in the group about the link and stuff. Anyway, so yeah, minor and cofactor. So the next part is there any part I'm missing? Then you can tell me as well, because there are many things in the week 1 and week 2 alone.
The properties of determinant.
Right, determinant properties. Let's see. Uh, properties. Okay. So, is that? Uh, just give me a moment. Mm, right. The first thing is, if you multiply or you take common from a determinant. For example, if you take, let's say, C, if you, for example, if the matrix is like this, C A11, C A12, C A13. Like 3 by 3 is writing 3 by 3 matrices are like very tedious process. So if you take common out of it, then for matrix, first of all, for matrix, it will be C, but for determinant, it will be C into C, determinant of And this thing, this distinction between matrix and determinant about taking the common term out, uh, it's very confusing, because in the questions, many questions in week one, I think IIT has use such problems where you're bound to confuse between these two properties. So in case of determinant, it will be c square, number of rows you're taking it common from, and in matrix it will be the single term. No matter how many terms you're taking, I mean, even if it, I mean, exists in all the rows, so it doesn't matter. In matrix, if C is common, I mean, in case of matrix, if A is A, B, C, D, if you multiply with the scalar P, it will multiply with all of it. That is the reason. Anyway, that is one. And uh, yes, the another one is, actually my note is a bit scattered, so it is taking time to find out. I've written many of it here and there. Uh, okay, so another one is, uh, in case of inverse, or I haven't talked about inverse yet. Anyway, so in case of inverse, the determinant of A is basically is equal to determinant 1 by of determinant of A inverse. Basically, if you calculate determinant of A, and if you calculate determinant of A inverse, they are reciprocal of each other. Does that make sense?
Yes, sir.
Okay. And there are problems in the activity question, or I think GA, about this as well. It's a very simple example, but simple property, but it's easy to miss if you don't know. Another one is yeah, determinant of AB. I mean, matrix multiplication of AB, and determinant of that is basically equal to determinant of A into determinant of B. And yeah, the thing I've said before, determinant of CA is equal to C to the power n determinant of A, where A is n by n matrix. And another one is, if a if A has two same rows, like for example B C A B C, then C D F, immediately the determinant of it will be 0, because you will see later that Gaussian elimination, by Gaussian elimination, will automatically make this one make our rows to complete 0, and if you do determinant according to that row, it will be ultimately 0, because if all the elements in a row are 0, expanding upon that row will result in a 0. And I don't think there are many important properties about determinant. If I remember anything anymore, I'll talk about it later. Uh, it would be better if I talk about one problem in the GA week one. Have you seen this problem in week one? Let me check first. I found it very interesting. Where is the problem? Wait, let me show it or write it. Yeah. So there's this problem in GA1 that says A is a square matrix of order 3. Means A is 3 by 3. And then it says B is a matrix. Okay. For that, I have to go for row in operation. Okay, let's talk about that. Uh, Let me check first. Is matrix populating with terms of row A. Hmm. Yes. Okay. So row operation of matrix. So we know there are three types of row operation is possible. This is not exactly week one, but this is mentioned in week one as well. Let me check. Yeah. So there are three ways to do row operations. Type one is type one is interchanging the rows. R1, R2. Type two is multiplying a row with some constant, like R1 becomes CR1, and type 3 is adding a scalar multiple to the row of the another. Like if I convert row 1 into row 1 plus some m into row 2. You know these three, right? So
Yes, sir.
in term, in terms of determinant, yes, this is why it is important in week one as well. In terms of determinant, in terms of matrix, changing this, doing these things does not change the ultimate properties of that said matrix. The matrix elements will change, the matrix will look different, but the ultimate properties, the properties that you look upon later, like the rank, dimension, span, etc. stuff, those in whether the matrix is invertible or not, these properties won't change. But for determinant, the value changes. Like in case of determinant, if I do this type of operation, the determinant value of A changes into minus of determinant A. I mean, what does that mean? That number of times I change the rows, the number of times a minus one is multiplied. For example, if I change changing rows m times will result in minus 1 to the power m determinant of A. I mean, the value will stay the same, but there will be a minus depending on how many of minus 1 will be multiplied depending on the time the rows are changed. And if I do this one, then in case of determinant, you cannot do it like that, like just like that. If you multiply with C, You are balancing it out with C. You get my point? Because suppose there is 1, 2, 3, 4, 5, 6, and you are calculating determinant of it. So if I multiply with 1 with C, like for example, if I multiply it with 5, I have to balance it out outside. Then I can multiply with here 5, 10, 15, 4, 5, 6. So that is one. And uh, this change, this does not, wait, this does not change, I think does not change the determinant. Keeps the determinant same, if I remember. If I'm wrong, correct me, any one of you, but as much as I remember, the determinant stays the same in this operation. So, and then in the problem I was going to explain, what is the problem? What is the problem? Wait. Uh, yes, yes, the determinant does not change. So the problem was that I was going to explain. Yeah, A is a square matrix. A is a square matrix of order 3. B is a matrix that is, of course, order 3, but that has been obtained by certain row operations. It is said that adding 8 times the first row of A to the third row of A, adding to the third row of A means third row of A has been added by the 8 times of first row, and then another operation has been done adding. This same problem is, I think, in your GA as well, but the values are different. And adding 9 times the second row of A to the first row of A. Like the addition is happening to the first row. So the first row, remember the pattern of writing. If it is written in this way, the change is happening in the row 3. And 9 times the second row. Yeah. So ultimately, the determinant value, this change is happening, and the resulting B value is B matrix we are getting. So as I was saying, the determinant value will not change. Determinant of A is equal to determinant of B. It will not change. Then in the question it said that determinant of A is 5. So by that virtue, it's also 5. And then said that find out determinant of A square 8 A square B inverse. What is the fun part about it is that all the properties that I've told you, it's being used here. So what is the first step? If I the first step, I have to bring out this constant. So if I bring out this constant, the determinant of CA is equal to C to the power n, determinant of A. So if I bring it out, it's 8 cube, because we know it's 3 by 3. Then A square B inverse. Then determinant of AB, I mean this term into this term, is basically determinant of A square, determinant of B inverse. Also, another property I forgot to mention, if you not square n, if you multiply A, the matrix A, n times, and take calculate determinant of it, you will get whatever the value you will get is equivalent to or the equal to calculating determinant of A and multiplying that value n times. So here it will be determinant of A whole square, and then it will be determinant of B. 1 by determinant of B. So 8 cube into 5 square in, by 1 into 1 by 5. So basically this type of problems where the properties are important, uh, is to be noticed first. Anyway, so I think week 1 covers this. Week 2, then the week 2 part, let me see what is important week 2. Yeah, first of all, minor cofactor I have mentioned, and then uh, yeah, cofactor matrix, right. I have already mentioned minor and cofactor. So adjugate or adjoint, I think adjugate is mentioned more. Adjugate of A is basically all the cofactors lined up, right? So if I and the transpose of it, you know the transpose of matrix, right? Anyway, so A inverse is basically 1 by determinant of A into adjugate of A, right? And what's left? Oh, right. The properties of inverse. Is that, where is that? Yeah. The properties of inverse. First one is A inverse of A into B. Like if you multiply two matrices and take inverse of it, it will be similar to B inverse into A inverse. And it's better to remember it this way than to think about an example matrix and check out whether it happens or not. You can do it for the first time, but it's better to remember it just this way, because when you're doing problems, these results will help you directly. For okay, so in case of transpose, if you calculate inverse of a transpose matrix, it is same as calculating transpose of the inverse matrix. The order changes, but the main thing is same. If you, this is 1, this is 2, so this, if you use a scalar, C is a scalar, of course C is not equal to 0. Take the inverse of that matrix, it will be 1 by C into A inverse. Next, inverse of inverse is A. Of course, the all the underlying assumption in each of the case is that A is invertible. Otherwise, there is no point of these properties. If A is not invertible, then if A inverse does not exist, then all of this is just null and void. The next one is, this one I have already said, 1 by determinant of A. The beauty of this formula is, if you know the determinant of A, you don't have to calculate the inverse and calculate the determinant. You already know the value. Just make like reciprocal of it. And this one, which is important in equation solving. Yes. So which brings us to systems of equation. So the one way to solving equation, the one way is, if we know, if we represent the whole set as a matrix, set of matrix like this, Ax equal to B, and A is invertible. Of course, the given assumption is A is invertible. Then it is enough. I mean, you can solve the equation. For example, like 2x plus y is equal to 3 and x plus 2y is equal to -1. For example, and I don't know if the solution exists or not. You can solve it in the classic way. You can replace x value in the second equation and bring out the y value, and then calculate the x value from the first equation. That is a normal way. But in the matrix way, One is the way is that if A is invertible, X is basically A inverse B, A inverse into B. Finding inverse of A, the coefficient matrix, and multiplying it with the B matrix, and you will get the uh, whole solution in a matrix form, right? The second method, I think, is, let me check. Oh, before second method, yeah. mm, the second method, this is method one. The second method is replacing the column with the B matrix. Like if the matrix is A11, A12, and A13, A21, A22, A23, A31, A32, A33, and here the X1, X2, X3, give the B1, B2, B3, then this is A, and now we introduce A1, like A1 for the simplicity of connotation, and that will be the same matrix, but um replaced, the first column is replaced with the B matrix. A12, A2, A32, A13, A3. This thing, writing it again and again is tedious, so let me do it this way. B1, B2, B3, and then the rest is B1, B2, B3. Anyway, so these are the three matrices, and then if you want to solve it, the value, then first one will be determinant of A1 by determinant of A, and the second one will be determinant of A2 by determinant of A, and third one will be determinant of A3 by determinant of A. And the third method of obviously that involves Gaussian elimination. Is that, where's that? Yeah, Kramer's rule, by the way, right? Thanks. I forgot the name for the moment. Yep. And the third method before that, we need to go for the Gaussian elimination, and before that, we need to know what is row reduced row echelon and reduced row echelon format. So actually, there are four methods. Both of them are connected with Gaussian elimination. So before that, row echelon format. What is row echelon format? Row echelon format is a matrix, and this part is, I don't know if I am being, I will be able to convey it clearly. I don't know whether you have gotten the clarity from the lectures. So in the row echelon format, first point is pivot element. And what is pivot element? The first non-zero element, this part, pivot. This, and if it's the first row, in this row, this is the pivot. And this is the, and this pivot element, the first element, if this is 1, is the leading entry or pivot. And Next part, so I use an example. I'll use the same example for the simplicity. Check what I'm doing here. This is the leading entry. The first non-zero element is 1. That is the first row. And column containing the leading one of a row is to the right of the column containing the leading of the row above it. The next leading entry for the next row, the next row leading entry must be either here or here, not here. So if I write it this way, and this is the leading entry of the row 1, and if the leading entry of row 2 is also, I mean, it can be 1, it can be anything else, but that's not the point right now. It is this, for example. This is not following the rotational format. This has to be 0. This has to be either this will be 1, or this can be 1. This is here 1 is, and I, or maybe this is also 0. The first leading entry, non-zero entry, is 1. It can be also here.
Sir,
But yes,
suppose the first row's first non-zeroth entry is 2, then it will violate the row echelon form, no?
you not necessarily.
Because in our
That's-
course it is completely mentioned that the first
Yes, yeah. If you, when you're actually, the problem is, you know what? The problem is in our course, Gaussian elimination is explained in one way. In general, it's a bit different. Yeah, you have to maintain 1 in the first place, and the next place you have to. Yeah, right. You are right. It has to be the 1. I mean, the first non-zero element, the entry of the 1, and it will be here. Actually, I haven't seen any such kind of example where the first row starts with the leading entry from this place. I haven't seen it yet in our course. And since that is the case, we can safely assume that this will be the format in general. The first one will be 1, because in Gaussian elimination, the first goal is you have to, your first goal is to make the first element as 1, right?
in our course it is described as that also.
Yeah, so I think that is like it's safer, because for now we have to pass the course. So it is better to follow what the course dictates, or what the problems or the examples dictate. So I mean, I think that is safer. And
Yeah.
as I was saying,
Sir, can the first row, first 1 comma 1 entry, means the first row, first column entry starts from 0, and the next entry is 1, and the in the next row the rightmost element will be 1, and before that always 0, then it will
continue again. Let's start from the top again.
like you have written in the second part 0, 2, 3, 4.
Yes.
And 0, 0, 0, 1. Is it in row echelon form? If I consider these two rows as a matrix, 4 cross 2 matrix.
See the for the rule for row echelon from they have said it does not violate that, because the first leading entry, if I make it 1, for example, if I can make it 1, I will do it this way, row operation. If I make it 1, the first, what is the first rule? First rule is the first non-zero element leading entry in a row is 1. First non-zero element, right? This is the first non-zero element. So it does not like destroy the rule, or this does not I mean, it follows the rule all right. It is the first non-zero element, and the next leading entry in the column, the column that contains the leading entry for the next row, the column contains that contains the leading entry for the next row is to the right of the previous leading entry, right? Tell me if I'm missing any rule here. Technically this can be a row echelon, but again, I haven't seen any example where they have purposefully given a row where the first term is 0 and the second it starts with the second element.
No, sir,
So
I haven't seen for now.
Yeah,
That
I mean me as well. Like
mm.
that's the beauty of telling someone about it, because someone will see someone has seen as something that I haven't noticed before, or I have noticed but not consciously. Like this thing I haven't consciously noticed before, that no, there is none such example, but this is the first time I'm thinking about it. Yes, there is none such. But by formula, by rule, by rotational form, the rules of rotational form, this one is not like neglecting any of the rules, I think. So anyway, so this is the row echelon form, and we can simplify it using row operations. As you all know, row operation, doing the row operation, all the row operations mentioned here. Where is that? The row operations mentioned here. We can simplify the matrix into row echelon form, and next is reduced row echelon form, more like the refined version of row echelon form, where the rules are said that similar. The first leading entry has to be one, number one, and all the subsequent non-zero rows. Of course, that is it requires non-zero rows, and the leading entries as one. And I mean, it's the same as before. It has to be on the right side of the previous leading entry. The column that contains one, for example, the example set shown 0010. Here, the next leading entry is 1 for the row 2, and this leading entry is that the column that it holds, it's in the right side of the previous column that holds the leading entry. And this leading entry is also has to be 1. And another thing is, the leading entry, each leading entry, it has to be the only non-zero element. Let me clear it up a bit. Anyway, then 0001, and then there can be a 0 row. So for
So the
each,
column having two, the second column, the column having two, can it have non-zero entries?
yes, because this is not the leading entry.
Okay. So how will it look then? Can you give an example?
Mm, yeah, like for example, if I put it here, like for example, we put it here 1. So the column that contains these two, there is another
Uh,
1.
but
But
for the
then,
second row, it
yeah,
fails, right?
it fails. Then it's not reduced
Yes,
form, right? Yeah, you can check it. Then you can check for this one. Then this is also not following because,
exactly.
yeah.
Yeah.
So yeah, I mean, most of the time you'll see it's an easy way. All these rules, forget all these rules. Most of the time, the reduced to echelon form looks like this. I think I've noticed this. This format. Like this is the perfect format of reduced to echelon, like RREF. This is perfect format. Yeah, some it can happen that this thing is not here. This one is not here. Just this one is here. Then there is no other way but bring only the 0 row, because if it is reduced row, then it has to be 0, this last row, because there is no other place for leading entry anymore, or any non-zero number anymore. It's like the the most filtered form, and you cannot go further beyond this. If you want to continue on this path, if you want to cancel out the elements and make it 0, like all the, I mean, the goal, the goal of all this Gaussian elimination is to make 0, right? Make element 0, cancel out elements, right? Change the matrix in that way, that all the selective elements will be 0. But reduced to what it does is like make as much zeros as possible. Like if there is all the zeros, if there are all the zeros in a row, then there is no problem. But make as much zeros as possible. So this type of format, like this format, or the thing I showed before, this format. This is very much RREF. So look for that, and you'll have an idea that you are looking at a reduced to echelon. Okay. Yeah, we have one more. That is what I was going to say. So, oh, by the way, yeah, I remember. There is another way to do inverse, but that I'll come back later. Okay, so Gaussian elimination. If I do Gaussian elimination, do I need to explain Gaussian elimination, or you guys already know it?
Sir, we know that.
Okay.
Actually, sir, I am facing lots of difficulties in vector space finding. In vector space, when they are asking for this is a vector space or not, is this following all the rules of means closed
Okay.
addition?
Okay. See, this is why I was asking to reply, because I thought it's a division situation. I was revising. Okay, so I think I don't need to explain augmented matrix or like that, right? You know
Augmented
that.
easy, na? Just
Yes, if it's easy for you, then I won't deal with it, because dealing with matrix is tedious enough for me at least.
but how others think you can?
Yeah, that's what I'm asking.
As far I know that augmented matrix is having all the minors. Am I right?
No, not all the minors. For example, augmented matrix is this. If the solution is this, you remember, you understand this, right? Ax equal to b. So augmented matrix is putting these two matrices together and this separator between. Like, for example,
That is clear. Yeah, yeah, that is clear. Yes, I
yeah,
know it. Yeah, yeah,
yeah. Then you have to transfer, like, reduce it to reduced row echelon form. Like, as I was saying, this format you'll see,
yeah.
and
Yes, yes,
there will be a certain b1, b2, b3, and you'll get all the solution from this.
yes, yes. That is clear.
Then
Yeah.
if the last row comes 0, then you can put b3 equal to 0. Yeah.
Yes, b3 equal to 0, but if the last row comes 0 and there is a b3 that is non-zero, for example 2,
Hmm.
do you know?
Yeah. Then we don't have any solution.
No
Right.
solution.
Yeah, and if all the zeros are here and there are, and if in this case, if this is 0, I mean, I'm changing the matrix a lot. Can you tell me what will be the solutions of the nature of solution in
So
this
it is
scenario?
absurd, sir.
No, it is
Uh,
not absurd. It is infinitely many. If there,
Infinitely many solution.
yeah, it's not absurd. Absurd is when there are no solution. Infinitely many. Means you won't be finding any unique solution.
No, sir, this point I have a doubt. Thanks a
Yeah,
lot,
tell
sir.
me. Acha. And you know what is what this the dependent variable and independent variable, right?
Hmm.
If
Sir,
the
this,
The leading entry with one, they are dependent,
yes,
and the rest are independent. We can
yes,
put
perfect.
any arbitrary value for independent to
Yes,
solve. Yeah.
yes, perfect. Yes, coefficient matrix. Yeah, the column matrix. What are you going to say?
sir, so in that case, when we are reducing it in row echelon form, there is some questions given to us that where they are asking for some, they are giving steps and give a matrix, and after that they are asking which matches with the other, means
Can you
matching
can
technique.
you can you can you
Mm,
can you show me the problem? It will be easier.
Problem number I forget, sir. Actually, I have practiced, and where practiced.
I
Mm,
also can understand what which problem you're talking about, but I cannot figure out right now because there are many problems in this
That's why I
Gaussian emission.
also forgetting. Okay, sir. If I can remember, I will tell you.
So can we dedicate to week 3 and week 4?
Yeah, sir. Week 3 and week 4 are much tough.
Okay, okay,
Yes.
okay. Okay, so week 3.
सर रिकॉर्डिंग कहाँ मिलेगा इसका इस सेशन का
I think someone posted a link. देखो यहाँ पर chat box में.
वो तो डायरेक्ट आपके मैथमेटिक्स फॉर डेटा साइंस 2 के यूट्यूब चैनल पे ले जा रहे हैं
अच्छा, एक काम करो, वो जो गूगल स्पेस में जहाँ पे नोटिफिकेशन मिला था ना, जो नोटिस, वहां पर पूछना।
ये नहीं, ये पूरा मेरे वो कैलेंडर पे शेड्यूल कर दिया है।
नहीं नहीं, रिकॉर्डिंग यू मीन यूट्यूब वीडियो राइट?
यूट्यूब पे स्ट्रीम नहीं हो रहा है ये
ओके,
शायद गूगल ड्राइव।
रिकॉर्डिंग अपलोड होगा राइट?
रिकॉर्डिंग कहाँ पे?
Oh, then you can get it in the calendar as well. Calendar में recording का वो either the file is uploaded or the link. I mean the drive link.
ओके।
One or two will be there. Like you can click the link and it will take you to the video. Or in certain cases, I think the videos are shown in a video icon and वो direct stream होता है drive से. Although that streaming, I don't know. I haven't checked that streaming. It's not like YouTube. But yeah. Anyway, vector space, right?
अच्छा
Yeah.
अच्छा, ठीक है ठीक है।
Vector spaces. So, like, what is the doubt? Like, let me listen to that first, then I can help you out maybe. Or should I go from the definition?
How I send you the doubts, sir? Actually,
No. Your doubt in, I mean, not the problem, the question. The
question. The screenshot sharing isn't permitted in Google.
Okay, no, that okay. You can tell me the problem number or anything, but later. But you know what is a vector space, right? The vector space is basically like a set of vectors that, like, it is a set of vectors. Like, think of it, a vector space is like a, like, it will be better to give you an analogy. Think of it like a playground, like school playground or playground behind your house or whatever it is, a playground where vectors are the players. Okay, and this is the playground. And what is going on? We are going on by two operations. Like, so we are playing a game, and there are only two rules we can follow. One is vector addition, and one is scalar multiplication. And you know what does that mean, right? Vector addition says, like it's a that if I take one vector and add another vector, the resulting vector has all that must also belong to the same playground, same space. So the first thing you have to remember that it's like a, like, for example, like the first example it comes along with the vector space is the if we think about R2, if I take one vector and if I take another vector, then if we add these two, the resulting vector also lies here, right? So that is the first thing. The second thing is if I multiply vector with C, a scalar, that also belongs to the bigger vector set. I mean the bigger the set of vectors, or the, if I call it a V, this also belongs to V, this also belongs to V. So this part we know. So one thing always remember, whenever the problem, like for example, I think it would be better if I show you the example from the GA, right? There is this problem where all the examples, like,
Yes, GA. In GA, there is a problem.
Yes, please. Yes, please.
yeah,
The problem, and the same kind of problem is asked in the mock assignment for Quiz-1.
okay, let me show you.
Actually,
Yeah, and wait, I'm sharing this screen.
Actually, the screenshot taken isn't allowed. That's the main problem. Otherwise, it's be very easy communication with you.
Yeah, yeah, I know. Let me just share the. Where is the window? Tab. Let's make 3. This one you're talking about, right?
Today I also practicing this.
Yeah, and be sure that there will be at least one problem in GA, which will look like this. Like this is like fixed. You're supposed to get this. Even in intern, they even, like, like intern, they give questions from the previous weeks, right? And there is a chance that you'll get one question that will look like this in that
Hmm.
in the intern, and they tie up the later concepts with that question, like the classic degree, our degree question style fashion. Like that is the thing they always do. They will bring some previous question and mold it with the new concept. So this will be always there, like in quiz 2, of course. In quiz 2, maybe quiz 1, of course. Is quiz 2, I don't remember, I don't know, but in intern, yeah, there's a big chance. So yeah, so what is the goal of this problem? You have to check whether each of these is following vector. Are they following those rules? By the way, those rules are that is the scalar multiplication and the vector addition. That is called the rule of linearity. I don't know if that is mentioned in lecture or not. That's called rule of linearity, and you have to check in each cases those rules are being followed or not. So what is the goal here? So first I have to write it. Let me write it so I can do it in a better way. For the first one, we can see. Oh no, there is another way to do it. Wait, and screenshot it.
Sir, you can take a screenshot and paste it on your notebook.
Yeah, I know, that's what I'm doing. I forgot where is my screen. Yeah. So if I show you the window, let's do. Is this okay now? So to check whether they are vector spaces or not, I like the thing I noticed. I'll tell you that. First, look for the discrepancies. I mean, this may sound a bit weird. First of all, check the first one: x1 plus x2 x1 y1 plus x2 y2. Then the result is x1 plus x2 comma 1. So this part is following the rule. We know that x1 plus x2 is becoming x1 plus x2.
Hmm.
But
But
the next part is a
hmm.
bit confusing. Similar for here. This part we understand, but this part is not very understandable.
Hmm.
So what they have done in the if you have checked the solution, you will see the pattern there right away. They have introduced a zero vector. They have said that v is equal to a zero vector. If I introduce it as a zero vector, then what will happen? If I add a vector u plus v, it will become u. I mean, if you add a vector with a zero vector, it will be zero vector.
Yes, yes,
You know,
yes,
you know those
yes,
properties, right? Those
yes,
axioms.
yes.
Yeah, yeah. Anurag, Anurag is. Are you trying saying something? Anyway, so if that is the case, then we will will check whether these rules are following that part, that zero vector rule. So first of all, we are saying that what is that? Yeah, if u plus v, u, let's say u is uh, a b, or these notations are very confusing. Like, okay, let's say x1 ab is better. And oh no, ab is already zero vector, sorry. So x1 y1 is, yeah, there. So u plus v is equal to u, but u is x1 y1 plus v is a plus a comma b, and then u is again x1 y1. But this addition, we has to follow this rule, right? This rule. So if this is the rule they're following, then 1. But y1 is not is equal to 1. We haven't said that y1 is equal to 1, right? So then lies the first contradiction. Tell me if this is I know this is a bit weird for me. At the first time it was also weird for me as well. So tell me if this is making any sense. I think better would be if I take a value like 5 6. This would be 5 6. But 6 is not equal to 1.
Violating the property.
Validating the property. So if this is validating the property, you don't even have to check for this one. If you check for this one, it will also valid. You will see. If you check this one, like C, for C, take C as 3. Okay, and take this as
5 6 remains same.
yeah. It also valid. But last में ये 1 आ रहा है. So why are we doing this? We are taking one property, we're choosing one property from the vector space, and pitting it against the rule they are providing. And we are choosing the property with our convenience. So that's why in the solution they chose this property, because this is immediately countering. Maybe there is another property I haven't checked, because this is enough for me. This was enough for me, and I haven't checked any other property. You can check other properties and see whether that will giving you any contradiction or not. But this is one property that is giving you easily the basic contradiction. The second one, if you check the second one, second one here you can see the first one is fine. The first one is fine. X1 y1 x2 y2 x1 plus x2 y1 plus y2. The problem lies here. There's a 0. So it implicates that अगर स्केलर से मल्टीप्लाई करेंगे तो 0 आएगा. ऐसा होना मुश्किल है. Like there may be a problem with that, so I have to check that. तो C का स्केलर ले लो. ये तो ऑप्शन ऑप्शन 1 लिखना चाहिए मुझे.
ये तो मुमकिन नहीं लग रहा है, क्योंकि अगर 0 से मल्टीप्लाई करेंगे तब 0 आ सकता है.
Exactly. So अगर मैं यहाँ पर 2 ले लूं, यहाँ पर आ रहा है. हाँ, हेलो.
Y has to be 0 in that case.
Because the rule dictates. See, vector space, the linear algebra part, like let me refresh this for you as well, because I felt this problem. Linear algebra seems very complicated at first because it builds the foundation, like foundation in the sense not our degree foundation, the foundation of math. Like जब तुमने स्कूल में पढ़ा था कि 2 + 2 4 होता है, we knew 2 + 2 4 because it said that 2 + 2 4. We didn't question it. But there is some book where it has proved that 2 + 2 4 ही होता है. It has been established. It has been defined. The math is based on basic definitions. Like some of those definitions you have seen, the properties you have seen in vector, that is also applicable for normal mathematics. Like this associative property that A plus B plus C is equal to A plus B plus C. Like no matter जिस कौन से ऑर्डर में भी तुम एडिशन करो, एडिशन का वैल्यू सेम रहता है.
रिजल्ट वही आने वाला है.
हाँ. So ये वाला सिर्फ वेक्टर के लिए नहीं, ये जब तुमने पहले स्कूल का मैथमेटिक्स किया तो वहां पर भी ये रूल था. The problem is our school mathematics doesn't teach you that way, because or maybe mention it once or twice and they like tell you to forget. But this is the basic fundamental definition. That's why we cannot divide 5 by 0, because it is not defined. It does not mean infinity. There is a misconception.
Undefined, but
it's undefined because we have not defined that. So math is based on definitions, right?
So we put infinity when we integrate those things and
Yeah, like that is also definition, but see, this is the definitions. Infinity also follows a definition. Everything has a definition. When it's not defined, it does not have any definition, we call it undefined. That is one thing. Even now, think of it, vector, this linear algebra is the same thing with, like, the we are establishing new rules to do the problem. The problem is that our understanding, what it struggles, we already knew the school mathematics, we already knew the rules for scalar. Now we have to understand rules for vector, which is a bit similar to scalar but bit ambiguous as well,
Hmm.
because that's why, because we are not entirely learning a new thing, we are learning new thing mixed up with the old thing, right? So now, the coming back to the question, why zero? Because it has been defined here, we are defining, that is the rule. What I said just now, vector space is a playground where there is a certain rule. You cannot, like, if you like play a football match, there are certain rules you have to follow, right? Otherwise it won't be football. So there are certain rules, and this rule they are establishing that you have to follow this rule. Now the question is, I have told you the rules. Now tell me whether this playground is valid or not. Does it make sense? The question is asking that to you,
Hmm.
that these are the rules. अभी मुझको बताओ कि भाई ये स्पेस हो सकते कि not. Or can you please write out the properties? You mean the vector properties? I can write it out, but okay, I can write it out actually, but you have to, like, have patience. The first property is okay. Like, should I write it out here? Where should I write out? Okay, I'm writing out here. I'll shift it later. The first property is u plus v plus w is equal to u plus v plus w. That is called associativity or associated property. I mean, you can change the order, but the value will stay same. Associativity. The next is u plus v is equal to v plus u. This is called commutativity. Writing this will be even more time consuming. Commutativity. I mean, the order you, I mean, the first, you can add the first matrix to the second, you can second add the second to the first, it does not matter. And the third is, discusses the zero vector. Like, remember, we have, as similarly as we have zero in normal numbers, scalars, that we also have zero in vector. So there is a zero that belongs to V. So that is the part. Zero is a special vector. Zero is a unique vector. Remember, Saras told about this in the lecture. It's a unique vector. Why unique? Zero, there is only one zero. In every vector space, there is only one zero. Remember that. And so in every vector space, there is a zero, and it follows this property. And this is the property we are using here. Okay, someone already listed it, all of it.
He's
Should I
already.
write? Yeah, should I write out the rest?
Sir,
Okay,
all those things are given in the lectures and books.
yeah, exactly. That's why I wasn't writing it out. I just mentioned it in the passing that these properties, this list of properties, they were in the scalar, and they are in the vectors as well. And this is the axioms. This is the, like, this is the thing it has to follow. Then
So
the
all
question,
those things together calls this axiom of vector
yeah,
space.
yeah, axioms of vector space.
So,
You can call it properties as, yeah,
so
yeah.
can you please explain it again? It's not make sense to me.
Which part?
Yeah, this question, sir. The
You mean
vector
this V?
addition and scalar multiplication part.
You mean the option two part? This one?
Mm, you can
Or
explain anyone.
okay, so the question, okay, the problem, okay, the problem to tell you the problem in simpler way. Suppose, suppose I tell you, see, you know the how additions work, right? You
Yeah.
know that 2 plus 2 equal to 4, because our entire number system, 2 plus 2 is equal to 4, 3 into 2, basically repeated addition. You add 2 3 times, then subtraction, division, etc. Right? Those are the rules that have been set, and your mathematics based on that. Suppose I tell you about a new mathematics where 2 plus 2 is equal to not equal to 4, 2 plus 2 is equal to 5. You can tell me that this is wrong, but I'm telling you it's not wrong. I'm telling you this is how I'm defining it, and my rest of the mathematics will based on this rule. I mean, I know visualizing it is very hard. I know it's impossible, but you are setting the rule and setting your universe based. It's like physics. Our universe follows a particular rule, say rules of physics, right? You cannot go beyond that rule of physics. You have to follow gravity. You have to follow momentum. You have to follow all the rules that comes with it, relativity and stuff, and all the things we know about physics. But like I'm just going on a very tangent topic here, not at all connected to this. But their scientists believe that there are other universes where the rules of physics is entirely different from ours. Entirely different. The rules does not follow our rule. I mean, not similar to our. There is certain difference. Maybe the gravity, the gravity does not exist. Maybe the temperature changes doesn't follow like ours. So that universe is following that rule, right? So here the problem dictates that here are my rules. See, where your confusion is coming from, you know that if I add two vectors, sorry, it will be like this, right? That is what you understand.
Yes.
And if you multiply this, it happens this, right?
Yeah.
But these two, see, remember what I have said here. I have said if the vector space, the rule of vector space, the absolute thing it has to follow, that these two are being consistent. Like I have said that if I add two vectors, the result will belong in the same vector space. मैंने ये नहीं बोला कि वो वेक्टर का एडिशन कैसे होगा और वो एडिशन का रूल क्या है. मैंने ये नहीं बोला. मैंने बोला अगर मैंने ऐड किया तो एडिशन विल स्टे इन द सेम वेक्टर स्पेस. अगर मैंने इट्स लाइक तुम XY प्लेन को समझो. अगर मैं 2 और 2 4 किया, 4 भी XY प्लेन में रहता है. लेकिन मैंने ये नहीं बोला कि 2 और 2 वो एडिशन का रूल क्या है. लाइक 2 और 2 4 ही होगा या फिर 5 होगा. ये मैंने नहीं बोला. द सेकंड वन, मैंने बोला कि अगर मैंने स्केलर से मल्टीप्लाई किया तो द रिजल्ट विल आल्सो स्टे इन द सेम वेक्टर स्पेस. आई हैवंट established the rule of that multiplication. I mean the exact nature of the multiplication. Since the problem lies, since we have done this method of multiplication and addition, the most basic two mathematical operations, not just for scalar, I mean vectors, it's for scalars as well. We have done this in this way from our early age. So we think this is the only way. This is not the only way. There can be other way. ये rule पहले set किया गया था. Then our method, rest of the mathematics has developed on that set of rules. समझे? ये rule पहले ये जो मैं बता रहा हूँ यहाँ पर, ये rules किसी ने set कर दिया है. Okay. And then बाकी के mathematics उसी rule पे चल रहा है. But that does not mean that this is the only rule and only right rule. There cannot be any other rule. ऐसा नहीं है.
Yeah.
Even for geometry, if you get time, I mean, all of us have studied about this in school. Search Euclidean geometry, the five rules of the 5 theorems of Euclidean geometry. You'll see that Euclid once upon a time said those 5 basic rules, like it's like basis of vector. Like those are the minimum 5 rules that you have to follow. Basis is like that as well, vector ke liye. Those are the minimum number of vectors you have to consider. I'll come to the topic very soon. So those are the minimum list of rules you have to follow that can build upon to the more rules and more mathematics. more operations. ये तो जानते हो ना कि एडिशन और मल्टीप्लिकेशन से बाकी सारे ऑपरेशंस आ रहे हैं. तो यहाँ
Yeah.
पर जो रूल मैंने ये जो रूल बताया गया था ये एक रूल है. इसी रूल पे हम लोग नॉर्मली काम करते हैं. But there can be other rules, and those rules they have mentioned. Those rules they have mentioned that if these are the rules, like check whether these rules are valid. I mean, these rules. I mean, not that's not the right statement. Let me rephrase it. Whether those rules create a valid universe. Like if मैं अगर मैंने तुमको एक सेट ऑफ नया रूल बता दिया फिजिक्स का, मैं तुमको पूछ रहा हूँ कि ये रूल्स ये फिजिक्स के ये रूल से क्या यूनिवर्स हो सकता है, कोई ऐसा consistent valid universe हो सकता है. Like it's a similar question like that in terms of mathematics.
Yes, sir.
समझ में आया या फिर समझ में आया?
आ गया सर, बट क्या आप एक्सप्लेन करेंगे इस
तो
एग्जांपल को?
हाँ
sir,
हाँ
with
हाँ.
that case, the fourth option is the right answer, right?
हाँ,
Yeah,
फोर्थ राइट है.
fourth option is the right answer. Yes,
सारे
fourth option आपने
properties
सही.
Because वहाँ multiplication और addition ठीक किया गया है.
हाँ मतलब the thing we know usually it is
Yep.
following that rule.
तीसरे में देखिए सर, मल्टीप्लिकेशन बहुत ही बढ़िया है, लेकिन एडिशन क्या गड़बड़ किया है. थर्ड टर्म का
हाँ
R2
हाँ
वेक्टर स्पेस को R3 बना दिया.
exactly that was what I was saying that इस ऐसे प्रॉब्लम में चेक I mean this also helps जो हम लोग को पता है, ये वाला हम लोग को पता है पहले से. अब देखो यहाँ पर कौन सा पार्ट है जो नहीं लाइक नहीं फॉलो कर रहा है, कुछ गड़बड़ है. दैट डज नॉट मीन दैट ये वेक्टर स्पेस नहीं होगा. ये हो सकता है कि वो वेक्टर स्पेस होगा. ऐसे ही प्रॉब्लम है. मैं दिखाऊंगा एक ट्यूटोरियल में एक प्रॉब्लम दिखाया गया था. वहां पर एक प्रॉब्लम एक वेक्टर स्पेस का रूल दिखाया गया कि वो एक्चुअली ये दोनों रूल फॉलो कर रहा है. वेक्टर स्पेस हो रहा है लेकिन देखने में ऐसा नहीं है. देखने में ऐसा नहीं है, ये वाला नहीं है. सो इट डज नॉट मीन कि वो वेक्टर स्पेस नहीं होगा, मगर हम लोग को चेक करना पड़ेगा वो कॉन्ट्राडिक्टरी पार्ट जो कॉन्ट्राडिक्टरी हो सकता है. जैसे तुमने बोला कि पार्ट 3 में यहाँ पर ये वाला कॉन्ट्राडिक्टरी है, ये वाला. सो हम लोग को ये चेक करना पड़ेगा. तो ऐसे ये अगर तुम अच्छा ऑप्शन 3 में ये देखो, यहाँ पर कॉन्ट्रडिक्शन क्या है. यहाँ पर कॉन्ट्रडिक्शन है कि 8 नॉट इक्वल टू 0. तो ये कॉन्ट्रडिक्शन है. ऑप्शन 3 में यहाँ पर मल्टीप्लिकेशन पार्ट हम लोग को चेक करने नहीं जरूरत है, तो ये छोड़ दो. तो वी हैव टू चेक दिस
Sir,
पार्ट.
sir, one request. We have last 10 minutes, right? तो आप वीक 4 का थोड़ा ऐसे रिवीजन ले सकते हैं क्या?
हाँ सर,
It will help.
जल्दी ये तो समझ में आ गया है.
हाँ, वीक 4.
तो बेसिस डायमेंशन और को समझा दीजिए, क्योंकि बेसिस और डायमेंशन में बहुत दिक्कत हो रहा है.
ओके. बेसिस और डायमेंशन कैसे निकाला जाता है वो बता दो. जस्ट ऐसे ही.
Yes, sir.
हाँ,
फर्स्ट ऑफ ऑल बेसिस क्या होता है ये पता है, राइट?
हाँ, लीनियरली
Basis-
इंडिपेंडेंट.
linear independent is the mathematical explanation. बेसिस ये होता है कि वो सिर्फ वो टूल्स लाइक वेक्टर का वो प्ले लाइक अगर तुम आई मीन अगर तुम क्रिकेट खेलने जाओ, आई मीन फुटबॉल खेलने जाओ, एटलीस्ट तुम्हें 2 प्लेयर लगेगा, राइट? अगर
जी.
तुम ऐसी गली में कोई फुटबॉल खेलते हो तो 2 प्लेयर तो लगेगा. अकेले अकेले फुटबॉल खेल सकते हो लेकिन वो ठीक फुटबॉल नहीं होगा. सो बेसिस इज लाइक दैट. यू हैव टू फाइंड एटलीस्ट द लीस्ट अमाउंट ऑफ.
क्रिकेट के लिए 2 लगेगा, क्योंकि
जरूर लगेगा. यस, क्रिकेट में जरूर लगेगा. तो मिनिमम नंबर ऑफ प्लेयर्स दैट यू नीड टू प्ले दैट that is called basis. So that is the basic. Oh, wait, someone tried to enter. So that is the basic concept of basis. So how to calculate basis, right? तो calculate basis यहाँ पर like थोड़ा confusion है. Like मेरे लिए थोड़ा confusion है इसलिए क्योंकि there are 2 ways to do that. I mean basis 2 ways actually. Rank के लिए 2 ways है. basis के लिए तुम्हें क्या करना पड़ेगा? तुम्हें first वो जो basis है, I mean जो vectors है, let me check first. हाँ, पहले जो वेक्टर्स है, सपोज मैं एक वेक्टर्स में बता रहा हूँ. v1 ऐसे लिखने का जरूरत नहीं है. 1 2 3 v2 4 5 6 v3 7 8 9. आई डोंट रिमेम्बर लेक्चर में क्या था, मैंने बाद में जो सीखा था कि टू फाइंड द बेसिस फर्स्ट अरेंज द वेक्टर्स एज कॉलम्स इन मैट्रिक्स ए। फर्स्ट एक मैट्रिक्स फॉर्म करो जिसमें कॉलम आ रहा है, राइट। अभी इसमें रो रिड्यूस करो, जो तुम्हें पता है गॉसियन एलिमिनेशन, रो रिड्यूस करो एंड उसके बाद ओ अच्छा रिमेम्बर कॉलम के हिसाब से ये होगा, अगर तुम रो रिड्यूस करोगे रो एशलॉन, तो इसमें क्या आएगा, फॉर्मेट ये आएगा 1 4 7 0 -3 -6 0 0 0। सो उसके बाद हम लोग ये -3 रिमूव कर दे सकते हैं, 1 4 7 0 1 2 0 0 0। सो पिवोट एलिमेंट किसमें है, कॉलम 1 में है, कॉलम 2 में है। तो बेसिकली द बेसिस विल बी v1 v2, क्योंकि तुम्हें नोटिस करना, ट्रैक करना जरूरी है कि कहाँ पे कौन से वेक्टर तुम पुट कर रहे हो, डिपेंड्स ऑन दैट। अगर ये वाला पिवोट दिखा रहा है ये कॉलम 1 में और ये वाला दिखा है कॉलम 2 में, देन v1 v2 विल बी बेसिस। अब एक और बात है कि आई थिंक लेक्चर में सैन ने रो के हिसाब से किया है, राइट?
लेक्चर में, हाँ लेक्चर में तो किया गया था उसके हिसाब से कि बेसिस ऐसे जो
या
है।
लेक्चर में वो कैंसिलिंग आउट कर रहा था, राइट? जो हाँ, वो तो तुम छोटे छोटे एग्जाम के लिए कर सकते हो कि तो सिंपल एग्जाम के लिए अंडरस्टैंडिंग के लिए, बट एक्चुअल प्रॉब्लम के लिए वो हेल्प नहीं करेगा तुम्हें।
और एक चीज, जब एकदम वेक्टर स्पेस दिया रहेगा उसमें लिनियर डिपेंडेंस ढूंढना है तो तब बहुत दिक्कत की बात हो जाती है।
हाँ वो तो होता है, वो एक्चुअली टीडीएस है, वो उसका कोई शॉर्टकट नहीं है। लाइक अगर तुम किसके बारे में बात कर रहे हो, वेक्टर की या फिर मैट्रिक्स की?
मान लीजिए R3 का वेक्टर स्पेस है,
हाँ
उसमें 3 बेसिस है,
हाँ
और 3 बेसिस में से एक अगर दूसरे की लिनियर तो दूसरे की स्केलर मल्टीपल हो जाए, बाकी दूसरे से अगर उसको बना दे तो तो एक हिसाब से वो लिनियरली डिपेंडेंस हो जाता है, वो वाला आखिरी वाला। तो
हाँ
पहले दो वाला अगर खुद में अगर नहीं है तो हम डायमेंशन 2 बताते हैं उसमें।
वो इस वहां पर भी रो रिड्यूस करना जरूरी है तुम्हें, रोशनन वहां भी जरूरी है। तुम
अच्छा, उसको उसको हम क्या करें, उसको रो
देखो वो तुम दो तरफ से कर सकते हो। तुम सपोज आई थिंक देयर वाज दिस एग्जांपल,
एक काम करो, ग्रेडेड से उठा लो एक अच्छे खासे।
से ग्रेड 4 में, राइट?
हाँ ग्रेडेड 4 में होगा शायद, या फिर मॉक टेस्ट से उठा लो, नहीं होता है तो
मॉक टेस्ट तो मेरा और तुम्हारा सेम नहीं होने वाला, बट ठीक है देख रहा हूँ।
कुछ ना कुछ तो हो जाएगा, बाकी समझ में आ जाए बस।
ग्रेडेड से आई थिंक एक सिंपल वाला एग्जांपल था जो रुको मैं बोल रहा हूँ, सिंपल वाला एग्जांपल। हाँ जो सिंपल एग्जांपल था ना, जो 5 2 सर ने बताया था, 5 2 एंड 1 3, ये वाला है R2 में। हर एक बेसिस के कॉलम बनता है जिसमें हम RF में कन्वर्ट करके निकलते हैं। हाँ वही मैं बता रहा था।
5 और 2 तो फर्स्ट कॉलम होगा।
हाँ रैंक का बेसिस कैसे फाइंड करते हैं मैंने किया था।
तो
हाँ
उससे मैट्रिक्स बना देंगे बेसिस से।
the basic the tedious part is like doing it this way, like x यहाँ पर तुम x लो, ये कॉमा ये करो, प्लस y लो, ये करो, this is the tedious way। and जब ऐसे स्मॉल स्केल का होगा, R2 का होगा, ये तुम ऐसे कर सकते हो, तुम ऐसे
आराम से निकल जाएगा वो।
जब बड़ा होगा तब तुम्हें बेसिस निकलने के लिए ये रूट जाना पड़ेगा, ये रूट में जाना ही पड़ेगा. रो रिडक्शन इज इम्पोर्टेंट. एंड आई थिंक अगर तुम रो के हिसाब से, दिस इज द इम्पोर्टेंट पार्ट, अगर तुम रो के हिसाब से इसको शिफ्ट किया, लाइक हाँ, अगर तुम ऐसे किया 1 2 3 4 5 6 7 8 9, अगर तुमने ऐसे किया एंड इसके बाद अगर तुमने रिड्यूस रेशनल फॉर्म किया RREF, तो उसमें जो फॉर्मेट आएगा, दिस इज द इम्पोर्टेंट पार्ट. जितना भी नॉन जीरो रोज होगा, सपोज यहाँ पर जीरो रो है, अगर सिंस यहाँ पर हम लोगों ने ऑलरेडी देख लिया कि 2 पिवोट आइटम है, सो बेसिस में 2 वेक्टर्स है, तो तुम अगर करके देखोगे तो यहाँ पर देखोगे कि 2 नॉन जीरो रोज आएगा. तो अगर 2 नॉन जीरो रोज आया तो वहां पर वो जो रिड्यूस्ड टू एशेलन फॉर्म में है उसका नॉन जीरो उसका जो रोज है वो बेसिस है. You don't have to go back to the original vector there. You have to, हाँ बोलो, डाउट बोलो. You have to check for the rows in the reduced to echelon form. Clear है?
Sir, please repeat once.
Okay. So अगर तुम इसका तुम अगर reduced to echelon form निकालोगे,
Sir, could you explain in English?
which one?
So the same thing.
Which same thing मतलब which one? This one that I'm explaining.
Last one you said no. That basis.
This one.
The next one, sir.
Next one means this one.
So the row thing. Row.
Thing. That is what I'm talking about. अगर तुमने ये वेक्टर्स को रो के हिसाब से सेट किया एंड देन
explain in English, sir. English.
Okay. Yeah, of course. If I reduce it in, I mean, do the Gaussian elimination and bring out the reduced row echelon form, and you can, you can do it and see what will come, because we don't have any time right now. Suppose there is a zero row here and there are non-zero rows, right? There are elements. For example, this is A1, A2, A3, B1, B2, B3. हाँ
सर, तो तब शायद रैंक इक्वल टू बेसिस हो जाएगा.
हाँ, right. Like, okay. First of all, let me finish. यहाँ पर, by the way, यहाँ पर क्या है? ये तो augmented matrix है ही नहीं. I don't get it. Augmented matrix का point कहाँ पे आ रहा? Oh, अच्छा, I'm not talking about augmented matrix here. I'm not solving equation. Augmented matrix only comes when you are solving an equation, system of equation. It is not talking about system of equation. I'm talking about basis. I'm talking about vectors basis or matrices basis. This is a different thing. Vectors का basis discuss हुआ है. Gaussian elimination is the method that how you reduce the matrix. It's not connected. It's connected to the augmented, but it's not like that you cannot do Gaussian without augmented. Augmented is the form. It's a form you put into to solve the equation. You do Gaussian elimination on that. Is it clear? Yeah. So, for example, if I do the reduced to echelon form, and the format, this is the format, the non-zero rows are A1, A2, A3, B1, B2, B3, and this is the 0th row. So what is the basis then? The basis then would be the vectors here in the reduced to echelon form corresponding to the vectors here. So the basis will be A1, A2, A3, and B1, B2, B3. So what is the difference here? Column ke, if I arrange it according to the column, we have to check the pivot elements and look back to the original set. If I arrange it according to the rows, we have to look to the reduced to echelon form and take the those row vectors, like take those row elements and make it a vector.
सर मीन्स हम तो
Means hmm,
बेसिक्स को कलम में सजाते हैं, तो फिर यहाँ से आप डायरेक्टली रो अगर लिख रहे हैं तो वहाँ पे
hmm.
एक दिक्कत हो सकता है कि अगर आप कलम को लिखते तो वो डायमेंशन 3 आ जाएगा, अगर ऐसा करेंगे तो डायमेंशन 2 आएगा आपकी।
डायमेंशन थ्री कैसे आ रहा है? तो यहाँ में तो ये दिखा है तुम्हें, यहाँ पर तो 2 पिवट कॉलम्स है, डायमेंशन थ्री कैसे आएगा? डायमेंशन 2 हो रहा है, dimension is coming as 2, right? There are 2 pivot.
हम्म, जी।
So, and the thing is the basis will differ. In this case, this basis will not look the same as this. Which one? This basis, this one, this 1 2 3 and 4 5 6. These two bases, these two set of bases will not be similar. They will be different.
Oh,
But
so number of pivot columns means A1 and B2 will be counted.
yes, yes.
Oh,
No, not A1 B2. No. You're mixing up again.
oh,
In this method, you don't have to check pivot columns. You have to make a reduced echelon form. You don't have to check pivot column. When you're arranging it according to column, you have to check pivot elements, pivot columns.
So
Okay.
then we should avoid the column method.
Yes, you can write the column method. This I said because sometimes I don't know if it in Quiz-1 or not. They give some certain options where the result will look different. The basis may look different. So, I mean, you have calculated the basis in one way, but the basis may look different in the option. So that is one reason. Maybe they have calculated it by the row method. I mean, by the second method. So this is I think quiz 2 in post week 4 you are definitely going to like deal with this. I don't remember for the quiz 1, but just for the sake of like being safe and everything, I've told you these two difference. Because merely, I mean, in my time when I went to attend quiz 1, this whole basis rank thing, like the process, this process gave me huge amount of confusion. That why am I doing from by rows? Why am I doing by columns? Which one is right? That was the confusion for me back then. So that's
हाँ,
why,
मेरे लिए भी वैसा ही है।
yeah, that's why, yeah, rank is number of non-zero
हाँ,
rows,
ये तो
basis
पता है।
vectors of non-zero. Yes, the merely confusion. Yes, my confusion is also lied in the method.
हाँ,
So that is,
मेथड बेसिस डायमेंशन का मेथड बहुत ही कंफ्यूजिंग लग रहा है मुझे।
yeah, and इसके अलावा, I mean, apart from this, is there any other doubt?
कुछ तगड़ा क्वेश्चन है मॉक 1 में, एक अच्छा वेक्टर स्पेस का क्वेश्चन था वहाँ पे।
दिखा सकते हो? I mean, screen share is not supported.
Supported, but I have another session now. That's why. From 6.
Oh, okay, no problem. I don't know how to get back to you with the answer problems.
Oh, so please tell someone and record the meeting is already recorded. Tell someone to show the question number 14 or 15. I forget.
14, 15 mock.
May 14. Let me check. I forget which question it was. Wait. Question number 6.
In which one, mock or GA?
Mock for quiz 1.
Okay. There is the problem. My mock will be very different from yours. Let me check.
14. 14 is okay. Question number 6. 6 after 6 there is 9, 6, 9 and 10. 6,
Wow.
9 and 10. Those 3. ओके, अब इसे क्या करें? आपको जल्दी से दिखाते हैं, रुकिए। दिख रहा है?
Which one?
This one, question number 6.
अच्छा, question number 6. First one, span S में रहता है कि if it belongs to span S or not, that you can calculate with the, like, you can put certain variables like x1, x2, x3 with these three, and equates it to the 7 minus 2, right? And then solve for x1, x2, x3. And if it has a solution, then yes, it belongs to span. And span S is a proper subspace of R3. Proper subspace of R3. Proper subspace, what is that?
No, I don't think.
प्रॉपर सबस्पेस का सबस्पेस तो जो सेट सबसेट ऑफ द वेक्टर स्पेस जो सिमिलर ये रूल फॉलो करता है, राइट? प्रॉपर सबस्पेस, ओके, द नॉट द एंटायर R3,
Not the entire R3.
because it's a अच्छा proper subset के तरह है, like the same definition as proper subset, the smaller part of it. Okay, it's not that. And span is you have to calculate the span is the similar way. In this case you can do it put the, like, see, in always try to attempt the first method, like the putting x1 x2 and solving it for that. If that is not working, then go for the matrix method, like the reduced echelon. Don't go for that first at the first chance, because that will eat your time up, because that's a very time consuming and error prone to error, because exam mein karoge, if you're doing it in the exam, you're bound to make error, so be careful about that.
अच्छा, तो फिर डायमेंशन सही है क्या इसका?
ये तो करके देखना पड़ेगा. You have to do it and check whether dimension is say, please get confirmed, am I right, in order to determine whether a vector is a spanning set or not. I don't understand your question. Whether a vector is a spanning set or not.
सर और एक देखिए यहाँ पे क्वेश्चन नंबर, या इसमें कंफ्यूजन हो रहा था थोड़ा, इन दोनों में. ये मुझे कहीं ना कहीं लग रहा है कि सही हो रहा है ये.
Set of all invertible matrices are ordered to form a subspace with respect to usual addition and scalar multiplication. And the first option is like, how can you be so sure that there is no there's no exception? How can you be so sure? Because if you consider the subspace and all of them are invertible, there will be some through some addition, there will be some matrix always. At least through some addition. Scalar multiplication you can easily ignore, because you are just multiplying the elements, right? You are not changing the element in the basic form. You are just multiplying with each element with a fixed number. But for addition, you cannot be sure the element will not, the result will not, it will not create a new matrix that is not invertible. You cannot be sure. It is bound to change that. So you cannot be sure about the first one.
Yes, exactly.
The second one, vector space R5 contains two disjoint subspaces. This one is not, like, I don't have any time to delve into this. Let me check if I have the similar problem, and whether they have the similar solution for it.
Okay, sir. So let's it be for now. I have some other sessions to join. So then.
Yeah, I think it would be better if you leave it for now, and see, mock they do give you mock solution before the exam, right? So it's better to go for the mock solution. Like, you can go for there. The basic thing here is to know the theory first. Theory, if you don't have the confusion in the theory or the method, the problem solving will always be clear to you. Do you have any other confusion regarding the method or the theory? it is, then you can ask or you can leave. There's no problem because it's already 6:12 and so anyway, कोई सस्ते स्पेलिंग सेट बने कि नहीं शेयर करने जो को शेयर करो आई मीन स्क्रीन शेयर करना चाहते हो पे कैसे चेक करूं आई मीन सबस्पेस स्पैनिंग सेट बनेगा कि नहीं स्पैनिंग सेट चेक करना is there is one way to do whether it's a spanning set or not. I mean that is also similar to the method I've shown here. Where is the screen? You can check it this way as well. If you check that all the pivot elements are present there, like if you those spanning set, put that in the column and do the row echelon and check whether the pivot elements are present in all three. And if all three pivot elements are present, like for the 3 by 3, then it is you can easily be sure that that is a spanning set. If not, then some subset of it is a spanning set. Okay. Let me just check once more. Because span is basically linear combinations of all those vectors, right? You are doing all, I mean, for example, if you think about R2, you are the set is like the basic concept is that you can, I mean, you can include another vector like 1 0 and 0 1. They are spanning the whole set, right? So you if you put it into the 1 0 and 0 1, like if you put it into here, so there you can automatically see there are pivot elements here. So that is one way to simply check whether spanning set is there or not. If there are two pivot elements, then this is span R2, right? Anurag? Like for example, it can be R3. The vectors are R3, number of pivot elements. For example, if this is this 0 1 0, then 0 0 0. So you find out that there are two pivot elements, but you have three vectors. So ultimately it span R2. Spanning set may have three vectors there, but ultimately span is R2. You have to check for, like, one way or another, you have to come back to this Gaussian elimination method. You have to come back to the Gaussian elimination. You have to eliminate all that elements. You have to make it a reduced. I mean, row echelon form is fine. Reduced row echelon is like making it double, triple conformation. And if you find two pivot elements, then you are sure about the actual span. Yes, number of pivot elements is the like the primary thing you have to look for. The problems, ultimately the problems may differ in the quality. Like there are many problems, IIT level problems, because IIT is very keen to make you confused. But the ultimate method is this: you have to go for the Gaussian elimination. You have to look for the pivot element. You have to calculate rank dimension from that. And since lecture in the lectures they had already shown you through by column, the arrangement column, then follow that. If you arrange by row, then follow that row. So that is another thing about basis I was told. Again, the whichever way you arrange it, follow that specific rule, and that's it. Okay. So anyway, uh, I think we should conclude this session here. Uh, Thank you for joining the session, and best of luck for your exam, especially for math 2 exam. So I'm ending this meet here. Goodbye then. I mean, Shun Shankar is here or not, I don't know. Maybe he will be able to. Acha, I will stop the recording as well.